In a couple videos ago, I showed you how to graph functions using the slope-intercept formula. In this tutorial right here, I'm going to show you how to graph the slope-intercept function using inequalities. Alright, so as we've seen earlier, previously, that y is equal to mx plus b, and this is the slope-intercept formula, where b is the y-intercept, and m is the slope, or the rise over run. In this tutorial right here, I'm going to show you how to graph them using y is greater than or equal to or less than or equal to. So the generic formula we're going to use for this one is y is greater than mx plus b. Alright, so it's still the same formula, it's just this is inequalities. So what does this all mean? So let's say that you have a greater than or equal than function, or a greater than or less than function, excuse me. The graph line would actually take on a dotted or dashed line. Now, if it's greater than or equal to, or less than or equal to, then it's going to be a solid line. So those are a couple things you want to note down before we actually start our lesson here. Alright, consider this problem. Y is greater than 2 over 3x plus 2. Alright, so this is in the y equals mx plus b form already. Alright, so I'm going to write down that formula just so you can see it. So what I'm going to do here is I'm going to first identify what the function is. So the function is actually a greater than. So this, I'm going to go and look at this, because I look at this, it's y is greater than. So it's going to be a dashed line, just like that. Alright, so now what I'm going to do here is I'm going to identify what the b, or the y-intercept is, which is 2. And then the slope, which is going to be 2 over 3. So that means every 2 units we rise up, we're going to go to the right 3 for the slope. Alright, so we're going to do similarly what we did in the last problem. So what we're going to first do is we're going to first start the y-intercept by graphing 2, which is positive 2. So that means I'm going to rise up to 1, 2 from the origin, just like this. Alright, then what I'm going to do is I'm going to follow the slope, which is 2 over 3. So I'm going to rise up 2 and go to the right 3. And from up this point, I'm going to rise up 2 and go to the 3 again. And I'm going to go down 2 from this point right here, and I'm going to go to the left 3. So now I have the appropriate amount of units, I could go ahead and start dashing a line. So since this y is greater than, I'm going to dash it, just like this. And it's not going to be perfect, but it's what it is. So I'm going to just dash the line just like this. So that's going to be the behavior of the line. So another thing we're going to do here is notice how y is greater than. So I mentioned how you have to draw the dashed line. So what I'm going to do is I'm going to shade above the the line. And the reason why is because y takes on all the values greater than this possible function right here. So what I'm going to do is I'm going to just simply shade above the line because y is greater than the whole function. So that's how you do a problem associated with inequalities with slope-intercept formula. Alright, I got one last one for you to try. Y is less than or equal to 2x minus 3. Alright, so what I'm going to do is I'm going to first look at this, the inequality. So y is less than or equal to, that means that's going to be a solid line. So that's going to be the statement or the behavior of the line. Alright, so what I'm going to then do is I'm going to look at the y-intercept, which is to be, or negative 3 in this example. So it's going to be negative 3, and then the slope, which is going to be 2 over 1. That's the understood 1 under the 2, by the way. So the slope is going to be 2 over 1. Alright, so now what I'm going to do is I'm going to simply graph this line like I normally would. So, or point the plots like I normally would. So it's negative 3 is the y-intercept. So we're going to go down 3 units, 1, 2, 3 from the origin. And it's positive slope, so it's going to be rising up 2 units and going to the right 1. And I'm going to rise up from 2 and I'm going to go to the left or right 1 again. And then from here, this 0, negative 3, I'm going to go down 2 and to the left 1. Just like that. So now I have the appropriate amount of units I could go and start graphing the line. So since y is less than or equal to, it's going to be a solid line. So that's going to be the behavior of the line. I'm going to simply draw it like this. And one more thing we need to do before we're done with this is we need to graph where the function is true, or shade where the function is true. So notice how the function is greater than all the y values, because it's greater than or equal to. Alright, so what I'm going to do is, since this function is greater than or equal to than y, I'm going to shade below the line, under, just like this. So, because that makes the statement true though, because like y is less than the whole function, or equal to it. So that's why I wanted to show you how to do these. If you found this video insightful, I'll post more videos on inequalities. I'll post more videos on algebra, calculus, and geometry and all that eventually. Thank you for watching. You have a good day.